Have you ever looked at a giant ship out on the ocean and wondered how it can just stay put, especially in a storm? Well, today we're diving into the pretty incredible tech that lets them do just that. It's called dynamic positioning, and it's basically an invisible anchor made of pure power and intelligence.
I mean, really think about that for a second. You've got this massive, building-sized vessel. Wind is howling, waves are crashing, and you need it to stay perfectly still, maybe just a few feet away from an oil rig or a wind turbine. How in the world do you pull that off?
Now, if your first thought was a really, really big anchor, you're not alone. But for a lot of these jobs, that's just not going to cut it. You need something way more precise, way more active, and honestly, a whole lot smarter.
So let's get into the challenge itself. Why is this such an impossible parking job for the old-school methods?
Okay, so the classic ways of staying put are things like a jack-up rig, which literally puts legs down on the seafloor, or using a whole mess of anchors. But what happens when the water is thousands of feet deep, or when the seabed is a spaghetti-like mess of pipelines and cables you can't disturb? Suddenly, anchors become impractical, super dangerous, or just plain impossible.
And to solve that impossible parking job, engineers came up with something truly revolutionary.
And here it is, the big idea. Dynamic positioning. So, forget anchors. This system uses the ship's own thrusters, its engines, its propellers, to constantly, actively fight the forces of nature. It's not about passively holding on. It's a non-stop battle to stay perfectly still.
You see, any ship out there can move in 6 different ways. You've got your roll, pitch, and heave, the up and down, side-to-side stuff that makes you seasick. DP doesn't really worry about those. What it masters are the other 3, the ones that decide where the ship is on a map. Surge, which is moving forward and back, sway, which is sliding side to side, and yaw, which is just turning. It's all about locking down that 2D spot on the water.
So, how does this magic actually work? Well, it all boils down to a really elegant 3-step loop. Sense, think, and act.
This right here is the basic blueprint. First, the system senses where it is and what the environment is doing to it. Then, it thinks, using some serious computing power to figure out what to do next. And finally, it acts, using its thrusters to hold its position. Sense, think, act, over and over and over, every single second.
It's this constant, relentless cycle. First, the ship senses its exact location and all the forces pushing on it. Then, its computer brain thinks, calculating the precise counterforce it needs to generate, and finally, it acts, telling its thrusters exactly how and when to fire to make it happen.
All right, let's break down that sense part. How does a ship know its position down to a few inches in the middle of the ocean? Well, it uses a whole bag of high-tech tricks. We're talking about super accurate differential GPS, lasers that bounce signals off of nearby structures, and even acoustic transponders on the seafloor that act like underwater lighthouses. And all the while, wind sensors are measuring every gust pushing on the hull.
And now for the think phase. All of that sensor data just floods into the ship's brain, a bunch of powerful, redundant computers. This is really where the secret sauce is. The computer has a perfect mathematical model of its own ship, so it knows exactly how it's going to react to a certain amount of wind or a certain size wave. It crunches all the numbers and figures out the exact thrust needed from each propeller to cancel out those forces.
And finally, we act. The computer's orders flash out to a whole network of incredibly powerful and nimble thrusters. And we're not just talking about the main propellers at the back. These are thrusters that can spin 360 degrees, firing with surgical precision to push back against the wind, the waves, and the current. It's what holds that multi-thousand-ton beast perfectly, impossibly still.
So this all sounds amazing in theory, right? But where do you actually see it being used? Well, the answer is pretty much everywhere in the modern offshore industry.
Of course, it's not a silver bullet for every situation. There are definitely trade-offs. The upsides are huge. It works in literally any water depth, you can set up and move super quickly, and you don't tear up the seabed. But the downsides are real too. These systems cost a fortune to install and run, they burn a lot of fuel, and at the end of the day, you're relying on complex tech and a very skilled human operator to make sure nothing goes wrong.
But even with those costs, its growth has been absolutely explosive. The very first DP ship, the Eureka, set sail back in 1961. By 1980, there were still only about 65 of them in the world, but by 2002, over 1,000. This technology literally unlocked the deep ocean for us. And trust me, that number is way, way bigger today. It just shows you how vital DP has become.
So what are all these ships doing? Oh, the list is huge. They're drilling for oil in deep water, laying the internet cables and pipelines that connect our world, building massive offshore wind farms. Heck, even giant cruise ships use DP to hold their position in pristine bays without having to drop a destructive anchor.
And if you want the absolute coolest, most mind-blowing application, here it is. Companies are now using dynamic positioning to hold giant platforms perfectly steady in the middle of the ocean, so they can launch rockets into space. It just doesn't get more futuristic than that.
So, when you pull it all together, what have we really created here? It's something pretty remarkable, an anchor that isn't made of steel but of data and raw power.
I think this just says it all perfectly. Every single second, on thousands of ships all over the globe, this invisible dance is happening. Sensors are talking to software, software is commanding raw power, all of it in this constant, beautiful effort to fight the chaos of the sea and achieve one single moment of perfect stillness.
And that kind of leaves us with one last question to think about. This technology was invented to solve the impossible problem of drilling in deep water. Now it's launching rockets. So what's next? As we push further into deeper, harsher oceans, what new, impossible things will this incredible, unseen anchor allow us to do?